integration with the power rule is quite simple. You just have to add 1 to the power. So there you take the power plus 1, right? And then you have to divide the whole expression by the new power. And that's it, basically. And don't forget the c at the end, but I will also show you how it works with an example. How to do integration with the power rule. It's almost the same as differentiation with the power rule, just the other way around. So how to do differentiation with the power rule. We have a function, let's say maybe 5x to the power of 2. So if you differentiate, the thing you do is you subtract 1 of the power and you multiply these two numbers to build the new coefficient. So if we differentiate, we have 10x, and if we differentiate again, we have 10, and if we differentiate again, then we have 0. So this is how it works. We have x times to the power of 1, x to the power of 0, and then it totally just disappears. Like then we just end up with 0. So the thing is, differentiation is this way, differentiation, and integration is exactly the other way around. So we have to increase the power by 1, and we have to divide by the new power. So this is how it works, nothing more. So let's just have an example. Actually, it's the same example. Let's have 5x to the power of 2. Now integrated, not differentiated. Then we write a capital letter F, and we indicate with a C that we are well aware that we integrate. There might always be something at the end that disappears when we differentiate. I will show in a second what I mean. So integration, as I said, we increase the power and we divide the old coefficient by the new power. So that you can always do, you can always make the test, like differentiate the integrated function. And so we multiply 5 divided by 3 with 3, so we end up with 5, and we subtract 1 of the power, so we end exactly up with the function that we had before. And what I just mentioned is c we need to add at the end, because of course when we differentiate we always lose this kind of information where the power of the x is 0. We can write x to the power of 0 always at the end, but this is just to show that there's a final element in our polynomial which disappears when we differentiate. So with the z we always indicate, okay, we know there might be some c, but we don't really know what it is because we lack this information. So we can also write something like this at the end, so we know the c is element r. So this is how it works, and what integration basically is. 5 times x to the power of 2, and we see it's probably something not so clear, but something like this, a parabola. And what the integration or the integrated function tells us, it tells us about this area. So it tells us what the area is actually. And this is how it works. So integration with the power rule, exactly upside down. Differentiation with the power rule, you have to increase the power and you have to divide by the new power, like the coefficient divided by the new power. And always, if you're unsure, do the test, differentiate the integrated function, and then you should end up with the function. That's how it works. Thanks for watching. Practice makes perfect. Further exercises with solutions you can find on my website, which is www.worksheeps.com.